electricity resistant would be 1. So COP is how much more energy you receive out of your kilowatt input in terms of energy. So COP of 4 would be you're receiving 4 times the energy output for a kilowatt input. Notice that the tier system, which is extremely complicated in California, that if you go to the top tier, you're paying about $16 per equivalent gallon for your electricity. And you'd think, gee, this is a real problem for an altherma, this expensive environment. Well, the answer is yes and no. Look down a little further below and you'll see that propane at $2.20 a gallon, which is, if you look online right now, is actually averaging $3 a gallon in California, is at that rate about $4.29 in terms of equivalent gasoline. You look at natural gas and it's less than half. So this gives you some orientation into the various cost of fuels. So if you take the equivalent propane at $4.29, natural gas at $1.75, you take electricity at 26 cents a kilowatt hour, which is in the middle tier range, which is a reasonable number to be at with these very stringent homes that are being built now. You can see that the altherma, when you use a COP of 3.5, that is dividing the COP into the cost of electricity, you're at about $2 an equivalent gas. So you're substantially below propane. You may be at or a little more than natural gas. This can be studied in more depth, but the point is there's the general orientation in terms of the economics out there. So what are some of the economic advantages? Any place there's propane, this is substantially less expensive to operate these than otherwise. When your electricity is below about 18 cents a kilowatt, very safely, you are able to be less expensive with an altherma heat pump. There are many municipal utilities within California where it's 13 cents a kilowatt and less. We'll go into net zero energy, but when we're looking at a condition where we're doing solar electric efficiency offsets and reducing the size of solar electric systems, with the altherma, it becomes a very attractive economic solution. And of course, there are people who want all electric homes. And of course, the altherma integrates the hydronic cooling, which has been an ongoing issue, economic and otherwise, for hydronics. So there are a couple types of systems we have offered here. Just move something out of the way. Altherma comes in a split system where we have an outdoor compressor unit and an indoor hydro box. And within that hydro box is the refrigerant to water heat exchanger, expansion tank pump controls, and other components we'll go into. And then you would have your outdoor unit and refrigeration lines running to the hydro box, which generates the hot and chilled water. Altherma also comes available in what's called a monoblock, which is essentially just taking the hydro box and the outdoor compressor unit and putting them all into one unit. And it's pre-charged, ready-to-go unit that generates hot water and chilled water. So if there are a variety of reasons, one may choose to put everything outside for space reasons or the fact that really don't want to have to do refrigeration lines. There's some constraints and issues attached to that, which we'll discuss. So the split system, we have here the outdoor condenser unit. We have the hydro box. We have an indirect water heater for generating hot water. It's an ideal application, which we'll go into further, using radiant floor heating and low temperature. This is a low temperature solution, 122 degrees maximum. So we're using low temperature radiators. We're using fan convectors, hot and chilled water fan convectors. We can use air handlers for distribution. Radiant floor heating is an excellent means of match with the altherma. Now with the monoblock, as you can see, all we've done is move the hydro box into the outdoor unit, and it's not here. We'll go into the integration with solar a little later, but this is a fully integrated program, and you'll see more as time goes on. So you know the altherma is the first of several offerings in the hydronic field that you'll start to see coming in next year. Daikin bought one of the major solar manufacturers that integrate heat pumps with solar thermal in Europe. So we'll see more and more on that, but we have now already integrated solar hot water solutions. So the altherma is really very simple. It's a modulating hot water generator. Think ModCon boiler, except that this is driven by a heat pump rather than a gas-fired solution. Priority domestic hot water, the same we've been used to dealing with ModCon boilers. And then we have a modulating chiller with the heat pump versions, where we can do space conditioning, we can do process cooling, we can do spot cooling as well. So where the smart starts is with the outdoor compressor unit. Daikin invented many years ago the inverter technology that's used within these devices, and what they are is they're basically modulating controls for changing the frequency of the and the rotational speed of the compressor to match the heating demand. So it's a load matching device. I think a lot of us understand already just how important modulating and load matching is to the overall performance of a system beyond what you'll see on paper. This characteristic is also very important for integration with solar electric systems in a net zero or otherwise design, because we don't have that on-off surges that occur with on-off systems and draw so much energy. So it's in a 3-to-1 or 4-to-1 configuration, so we can match loads. Also, the unit comes with sensors and is set up to attached to the outdoor unit is a sensor for doing outdoor reset. Highly recommend doing outdoor reset with these units. You can extract much greater efficiencies doing so, even on top of the inverter technology available here. Of course, with modulation, we reduce system cycling, which means overall system efficiency is higher, as well as the need for the big buffer tanks that you're familiar with geothermal heat pumps, on-off. The few on-off air-to-water heat pumps that have been available aren't required, and frankly cut a lot of cost and complication out of the systems. So this is just diagrams showing the load matching characteristics, particularly in relationship to outdoor reset, that are so attractive. The indoor unit is, if you've ever met a combi boiler, it looks very much like it, except it has no venting is required for the unit because it's electrical. It includes a heat exchanger, that refrigerant to water heat exchanger, an expansion tank, pre-charged, a 3-speed circulator that has quite a bit of oomph attached to it. This tank up towards the top, number 4, is sort of an accumulator tank that also has an electric booster in it, which we'll get into, but there are times where electric booster capabilities can be attractive in sizing your system. It has a pressure relief valve on the top of it and an air vent on top of it. Pressure gauges, and also the switching box, user interface, gauges. Basically everything is there. You pipe to your refrigerant lines, 5/8 and 3/8 to the unit when it's indoor, and you have hot and cold, your hot supply, let's say supply and return lines coming out of the box.